Hey guys, this is the video for homework number 5. I'm going to go through 10 problems, and I actually decided to do 2 of the beginning problems from last week's stuff. So you'll notice that HAA is actually a topic that we had done last week. But I had a couple of the questions that made me realize we had not talked about a couple of things, and we should. So the thing we didn't talk about is really whenever we're factoring, when you have instructions that say something like factor completely, there's a few different ways to handle this depending on how it's set up. But the first thing you're always going to want to check is for a greatest common factor for the whole thing. So we were doing greatest common factor by grouping, where we took the first 2 together, like in this situation, like the first 2 here, and grouped them. And we're going to do that with this problem. But the first thing we're going to check is there anything I can factor out of all of it? So I'm going to check that first. And then the next thing I want to do is I also want to make sure it's in descending order, meaning it's going from biggest to smallest exponent. And so this problem has issues with both things. So if you look through, the coefficients here are 24, 48, 42, and 21. So all of those have a common factor, a greatest common factor of 3. And then the other thing that's going on with this polynomial is that all of them have at least one z, which also means I can pull a z out as my greatest common factor. So really, this is the greatest common factor. So when I come over here to do this problem, the first thing I'm going to do is divide out a 3z. If I divide this by 3z, I end up with 8z left over. If I divide this by 3, I end up with a negative 16, right? But I took the z away, so now there's no z here with it. Negative 42 divided by 3. So that would be negative 14z squared, so 2 left. And then if I take 3, if I divide 3 out of 21, I end up with a positive 7. And I took 1 z out, so I end up with 3 z's left. All right, so this is step 1 here. So this was step number 1, where I took out the greatest common factor. Step 2 then is going to be to put it in descending order. So that's what I'm going to do next. So I have this 3z out in the front, so I'm going to keep that there. And basically, to be honest with you, I'm just going to pretend it's not there. It's like a child that's in timeout. It's just going to stay outside, and it's just outside of the group and be there until we decide to look at it again. So if you go through and put this in descending order, you're looking for the largest, right? So 7z to the 3rd, and then minus 14z squared. Then I have this 8z here, so that's positive 8z, and then that negative 16. So really, when I'm going through all this, this is the piece that I'm factoring by grouping. So I'm going to do this the way I always have done it before. I'm going to take the first 2 as one group, and I'll take the second 2 as the next group, and then just factor by grouping like last week's video. This 3z will just hang out in the front, and it'll be part of my answer. So my answer is going to have 3z, and then it'll have a parentheses and another parentheses. Make sense? All right. If I look at the other example from last week that I wanted to go over, this is kind of a similar situation in that it looks a little different, but it still follows the same rules. The first thing I'd want to check, right? I have to go through those steps. First thing, does it have a greatest common factor as a whole? And if you look through, there's a 6, a 3, a 12, and a 6. So I could factor out a 3, right? So I could take 3 out to the front. And then each one also has groups of h. So I could take h out to the front also, which is going to leave behind 2hg minus g, right? Because I took the 3h out to the front here. So this 3h went out to the front, and now there's negative g left. I'm going to have a positive 4h and a negative 2. All right, so then The other piece of this that's a little bit different is that there is two variables. So I remember I have this out front, it's just gonna stay here. So my answer will have this 3H here. And then when I go to start factoring by grouping, this is gonna have a 2. Oh, sorry, not a 2, but it is gonna have a G. So the thing that's in common for this one is G. And then I end up with 2H minus 1 left over. And then here I can take out a 2 with 2H minus 1 left over. So my answer is going to be 2H minus 1 and then G plus 2. So hopefully you were following along pretty well last week. So this G plus 2 comes from these two. And then 2H minus 1 comes from the same. This is my answer. All right, moving on then to this week's stuff. So this example is from IXL Topics ZED, and it's factoring again, but this time you'll notice that there's a coefficient out front that is not 1. So it's something different than 1. So in this case, it's 2. Luckily, it's not that much different than what we've been doing. I'm basically going to go through, remember like last week, and say, what's the product? What's the sum? And so the product and the sum, so the product comes from multiplying the 2 and the 9, so I get an 18. And then the sum is just this middle number, which is a positive 11. So I'm looking for two numbers that multiply to be 18, but add to be 11. And so then last week we talked about the idea that you can go through and you can write down pairs. Some students figure this out right away. And some students need to be a little bit more organized about it. It doesn't really matter. Whatever works for you is fine. If I do 1 times 18 or 2 times 9, so hopefully here is when you'd realize, oh, I can make 11 by adding those together, right? So I can multiply 2 times 9 to get 18 and then add 2 plus 9 to get 11. So the difference this week is that we need to add another step where we rewrite and factor by grouping. So it's really the same as what we were doing last week. We are basically rewriting. We're going to take the sum term, this one, this positive 11m, and we're going to rewrite it with these two so that we have 4 pieces. So I have 2m squared out front. I have the positive 9 at the end still. So this piece in the front and this piece at the back didn't change. I'm just rewriting this middle term. And the middle term, 11m, is going to be rewritten as a positive 2m plus a positive 11. Oh, no, sorry. I was looking at the 11. Plus 9. In order to make these add to 11. You see, if I went backwards, 2 plus 9 would give me this 11 up here. So now I can factor this by grouping. So I have this and this. And so here I can take out a 2m, which leaves behind m plus 1. And here I can take out a 9, which leaves behind an m plus 1. And so really my answer is m plus 1 times 2m plus 9. So this is my answer. If I want to check my answer, which you don't have to do, but you know, if it mattered, maybe if it was a test or something, you'd be more motivated to do it. But you could go through and do the FOIL or do the whatever, however it is you look at it, the distributive property, but just multiply it out and make sure that you get this back. All right, that was a lot of writing. So let's do less on the next one. So let's start with product and sum, right? So product is 2 times 5, which is 10. And then the sum is -7. So I'm looking for two numbers that multiply to be 10, but add to be a -7. And so probably 2 and 5 jumps out at you because 2 times 5 is 7, and you can combine these to make a negative, or I'm sorry, 2 plus times 5 is 10, and you can combine 2 and 5 to make a 7. In this case, it needs to be a negative, so I would really need to be putting 2 negatives here, right? So it'd be -2 minus 5, which is -7, and then I need to check, is -2 times 5 is -2 times -5 positive 10? And the answer is yes. So these are my two numbers. And so I'm going to take this now and I'm going to say 2m squared, and then that +5. And then I'm going to rewrite this middle term with these two. So -2m minus 5m. And so now I can factor by grouping the same way we have it. So 2m, that would be m minus 1. And then don't forget here, when you have a negative sign in the middle, that means this middle sign is going to be negative. So you have to, you carry that down. So I'm taking out a negative 5, which is going to change the sign here to a negative. Because if I divide out a negative, it's going to leave a negative. Negative times negative is what's going to make that positive. So my answer is m minus 1 and 2m minus 5. Okay, moving on. So I'm going to set some of these up. I don't know if I'll necessarily finish every one of these just because, you know, it's a little bit time consuming. Product and sum, 2 times 10 is 20. And then my sum is 9. So two numbers that multiply to be 20 and add to be 9, which hopefully you can figure out would be 4 and 5. And then these are pretty straightforward, right? I just do positives. So I'll rewrite this as 2q squared plus 4q plus 5q plus 10. So the 2q squared stayed there, the 10 stayed there, and then I used 4 and 5 in the middle to rewrite. And now you can go through and factor by grouping. So like this is kind of the place where I think I'll stop since you technically practiced that part already. We don't need to watch me do it 10 times. Okay, so product and sum here, if I do 2 times negative 2, the product is negative 4, and my sum is positive 3. So I'm looking for two numbers that multiply to be a negative 4. So my choices for 4 are pretty straightforward, right? I can either do 1 and 4 or 2 and 2, and I can't make a 3 out of 2 and 2. So I'm going to have to use this with some kind of negative signs. So it looks like 4 and a minus 1, right? So 4 times negative 1 is negative 4, and then 4 minus 1 would be positive 3. So these are the two numbers I'm going to rewrite in the middle here. I'm going to turn that into 4w minus 1w, or just w. And then this 2w squared stays out front, and that negative 2 is still in the back. And then from here, I would factor by grouping. Make sure you pay attention to the fact that this is negative, so you need to have a minus sign here. When you take out a negative, ooh, this is a good problem to do actually, because I don't know if we talked about this. 2w squared plus 4w, that has a 2 and a w, right? Which is going to leave behind a w plus 2. And then I have this negative sign. And since I can't take the greatest common factor other than 1 out of w and 2, I just take out a negative 1, which is going to leave, since it's negative 1, it's going to leave behind a w, and then this sign is going to change to a positive. So my answer is w plus 2, and then 2w minus 1. All right. Product. Ooh, actually, I was going to say, I was actually thinking it in the last problem and then forgot. Don't forget our steps. So remember the idea that you're supposed to check the greatest common factor. So the ones we were just doing didn't have it, but this one does. And so if you look, you have a 2 and a negative 20 and a positive 48. And so really you can take a 2 out of all three of those numbers, and it leaves behind k squared minus 10k plus 24. And so now, once I did this first step, the greatest common factor of 2, now I can go through and do product and sum. So, and this one actually is pretty easy because look, it has a coefficient of a 1 here. So when I do product, I'm really doing 1 times 24, so 24. And then sum is negative 10. And so I'm looking for two numbers that multiply to be 24 and add to be negative 10. And so hopefully you feel comfortable with 4 and 6. Because if I add a negative 4 and a negative 6 together, I get negative 10. But if I multiply those two negative numbers, I get that positive 24. These are the ones we did last week because it has a coefficient of 1 here after we factor out that 2. I can use the shortcut. Remember the shortcut from last week was that I just use k and k here and then plug these two numbers in, minus 4, minus 6. So that's one of the benefits of this coefficient by one idea, is that I can use this shortcut where I don't have to factor by grouping. I could, though, if you wanted to come over here and say 2 and then k squared minus 4k minus 6k plus 24, and then factor this by grouping, you still would end up with the same answer. It'd just be a little more steps because you'd need to go through and find, you know, those greatest common factors and do all that. So it'd be k and then the k minus 4. And then negative 6, k minus 4. So hopefully you can see that you'd still get the same answer, but it would just be more work if you do the factor by grouping. So this is a shortcut where you just plug these in. All right, moving on. Here's another one where if you think about that first step of greatest common factor, you do need to consider that for this one also. And, you know, it's kind of like reducing fractions. Your eyes get better at seeing these as you do more and more math. So I'm sure you kind of always know when you need to reduce a fraction in a lot of situations. When a lot of times when I look through these, I immediately know I need to factor out a 3 because I have 3 in common. So I can put a 3 out in the front, and that leaves behind a 2k squared, and then a plus 11k, and then plus 15. So now you can go through and do your product. Oh, I'm supposed to change blue. Product, 2 times 15 is 30, and then my sum is a positive 11. And so I'm looking for two numbers that multiply to be 30, but add to be 11. And so hopefully 5 and 6 jump out at you. And that's pretty straightforward, right? Because all these positives, I don't have to worry as much about the subtracting part. And so really this is just going to be 2k squared and then plus 5k plus 6k plus 15. And then factor by grouping. So from here, you're going to factor by grouping. Just don't forget that this 3 is going to stay in front of your answer. So your answer is going to have a 3 hanging out in front, and then whatever the parentheses are after you finish factoring it here in this part. All right, we're getting close to the end. This is probably a kind of long video too. The only other thing we need to talk about really, because we've kind of practiced a lot of those factoring types, is what happens if you have these things that they call special cases. And mostly the special cases are just kind of answers that are unique because they have matching parts on some level. So, I mean, they're kind of special, but I kind of feel like overall they're basically the same. But if you look at this, you'll see a different setup. Let's look at this like 25m squared plus 0m minus 1. And so I can still go through and do my product and sum the same way. The product here would be 25 times negative 1, so negative 25. And my sum is a 0. So I'm looking for two numbers that multiply to be negative 25, but add to be 0, which seems weird, but actually it's pretty easy, right? Because negative 25 is just 5 times 5. And so if I wanted to add to be 0 and be negative here, I need one negative. So 5 minus 5 equals 0. And then 5 times negative 5 is negative 25. So really, this is the same as saying 25m squared plus 5m minus 5m minus 1. And so then if I factor by grouping the same way that I have been, I'm still just going to look at these as one group, and I get 5m as my factor, my greatest common factor, and I'll have 5m plus 1 left. This is negative, so I'm going to do a negative, and I can't take anything out of this, so I'll put a 1. And then I end up with 5m, and then don't forget that sign switches to plus. So hopefully this seems like, even though it's called a special case, it's really the same. It's the same as what we've been doing, same rules. Just you have to remember that if there's nothing here, that means there's 0 of them. Okay, this is also considered a special case, this type 2. So let's go through and just handle it the way we normally would. So with such big numbers, I'd probably definitely want to check to make sure that I don't have a greatest common factor. So do I? 49, 28, 4? No, there's none. So this time there isn't, but don't forget to check. If I go through and figure out what this is going to be, This one is going to be big numbers. I can go through and do product and sum here. Product is going to get me this big number, and then a sum is going to get me this big number, but I could go through and still do it the same way. I will give you a hint though, that when this number is a perfect square and this number is a perfect square, then the special case is that you're going to end up with the square root of each one of those in each end of the parentheses. So this ends up being 7t. That's the square root of 49t squared. And this is going to be 7t. This is 4. And this is 4. And then in the middle, you're going to have one positive and one negative. Oh, no, hold on. Let me pause this. I'm going to pause the recording just for a sec because I'm going to pull up a list of rules so I can show this to you, and then I can also remind myself how to show it to you easily. Okay, I went back to 9 because I wanted to rewrite this answer because we didn't finish it, and then that way I can point out what I was going to try to show you that I messed up on the other one. If you look at the way the answer would be here, it would be 5m plus 1 and then 5m minus 1. So you'll see that these are related, right? Because this 25 is where the 5 comes from. It's the square root of those, right? The square root of 25 is 25m squared is really 5m. And then the square root of 1 is 1 and 1. And so because there's nothing in the middle, because there's this 0m, that's when you get the plus and the minus. So that's where these are opposites. So they have opposite sides for the constant at the end. In the middle, I guess you could look at it. So opposite signs in the middle. So that's what this special case is considered. This one, which I wrote wrong, but we'll correct now, is different because this one has a t in the middle. And so what that means is you're going to end up with the same sign. See, I've told you I'm not very good at memorizing those rules. So here you're going to end up with the same sign in the middle. Because if you think about what's happening here, you're doing okay, these videos end up being a lot like real class because in them I discover that I make mistakes just like real class, and it's so fun to try to figure it out. So then I pause it because I have the freedom to not actually do it in front of you. So I told you that this should be the square root of this number, which the square root of that number I had is 4, but it's not, it's 2, silly. So this, when you think about what's happening, when you multiply the 7 times 2 here and the 7 times 2 here, you're getting negatives both times, negative 14t minus 14t. And this is where that negative 28t comes from. So this answer, because these are the same, a lot of times you'll write that answer as 7t minus 2 squared, which I'm going to guess that IXL probably wants you to use these boxes to write this answer, where you're squaring this because you're multiplying it by itself, you know, so you're doing it twice. So I think I'm going to erase this and just kind of quickly discuss that again, because I don't want to have to re-record the video, but I also don't want you to feel confused. So the idea is that we went through and we looked and we said that the square root of 49t squared is 7t and 7t. And then the square root of 4 is 2 and 2. And then because this is negative, I'm subtracting them both times to get that. So I end up with a negative here, which since these are the same, it's really like saying squared like this. So that's also considered one of the special cases. So what I was going to show you is this, which I pulled up. So I didn't really like these kinds of rules very much when I was in school. I tended to forget them when I was stressed out on a test. So personally, I probably would have actually just gone through the work of going through and figuring out product and sum, because this always works. And I'm really a fan of always works. But the other part of this is that you're going to get a really big number here, 49 times 4. And you're going to have to probably play around a lot with the combinations that are going to create the product and the sum, which you can do. I just don't necessarily want to do on a video. But I probably would have done it on a test, just so you know. But in case you are the kind of person that likes to memorize those things, this is a pretty good Here, let me open it in a new tab. This is a pretty good list of them. So the special cases, if you have them in this setup, then the idea is that the answer is going to look like this. So if you had a plus here and a plus here, then that means that that shared term has a plus, negative and negative. Maybe looking at this, you can kind of see though why I don't really enjoy memorizing stuff like this, because it kind of just looks like a jumble to me. And I'm not sure it's very easy for me to keep track of that. So if you wanted to watch a video on this on YouTube, factoring special cases, you could probably watch someone that maybe likes it, doing it more this way, explain it, and maybe it would make sense to you. So I'll give you that option. But mostly I just work with this product and sum idea. I find that it's the most easy for students to remember, and it's the easiest for me to remember when I was younger. All right, hopefully that's helpful. You can always stay though. We have all week to work on this. So let me know if you have questions. Good luck.